Good morning all, my name is B. Santhosh Kumar, Assistant Professor, Institute of Aeronautical Engineering. My subject is Image Processing. Today I am discussing about Constrained Least Square Filtering. So what is Constrained Least Square Filtering? How it is related to the filtering? So the least square filtering function reduces degradation and noise in an image based on the mean and variation of the degradation and the noise. It is also called constrained least square filtering. It is the frequency domain estimation of the undegraded image. So it is also known as maximum square error approach. So what is the formula is n equal to g minus hf. So here g minus hf. So here we are estimating the original image as f dash and the noise as the n, and the maximum is the f dash equal to h g by h into 2. So the constrained least square filter is used as deconvolution, and after filtering process the deblurring image is decomposed into the texture and cartoons and parts of using curved transform. Constrained least square image restoration, first proposed by Hunt 20 years ago, is a linear image restoration technique in which the smoothness of the restored image is maximized and it is subjected to a constraint on the fidelity of the restored image. So what is the constrained least square filtering and how it is using? It is a 20 years back of the method, but it is the smoothing technique. It is nothing but a smoothing technique which are using in a constrained least square filtering. So it is a deconvolution method and it is the deblurring image. So which is the blurring is there, that is a noise, and deblurring image. So when I am going for the blurring, that is a noise. So when I am going for the deblurring, means I am using noiseless or filter. So deblurring means here filter is applied to reducing the noise or for the denoising. So constrained least square image restoration, first proposed by Hunt 20 method in a linear image restoration technique in which the smoothness of the restored image is maximized and it is subjected to the constraint of the fidelity of the restored image. So when I am going for the it is nothing but a smoothing technique. For the denoising and deblurring. So suppose I am taking image, figure A is the original image and figure B is a blurred image and C is a filtered with least square filtering. It is a least square filtering. It is a output image. It is the input. It is also input. But what it means here, the blurring is added here. So for the input image, blurring is added, means noisy image. Okay, it is a noisy. Noisy is added to the input image, that is a blurred image. So the original image with blurred image is a noisy image. So output is a least square filtering. It is the output image without noise, or it is a deblurring, means remove the blurring in the from the original input image. Okay, so comparing to the input image, output is a very much clarity. Why? Because we are applied smoothing technique to reduce the blurring and for the denoising. So it is one example of constrained least square filtering. So the least square filter function reduces degradation and noise in an image based on the mean and variation of the degradation and noise. It is also called constrained least square filter. So, if the degraded image is modeled in the spatial domain, that is the small g equal to hf plus nu. So, what is the g here? Output image, output, that is called constrained least square filtering, CLF. Okay, so it is a g is equal to h into f plus nu. Nu means noise is there. Okay, so it is a input. So input with noise is there, but when I am using the filtering, we have to remove the noise and we will get the original input. Okay, we have to remove this one and we will get this one. Okay, input equal to output. What is means we have reduced the noises. Okay, so the least square filter function reduces the degradation and noise in an image based on the mean and variation of the image, that is a degradation of the noise. It is also called constrained least square filtering. It is also called constrained least square filtering, CLS. So it is the degraded image is modeled in the spatial domain by g equal to hf plus nu. So the constrained least square CLS filter seeks to find the minimum of summation x into summation y into dou square into f of x comma y whole square. So summation x into summation y dou square of f of x comma y whole square. So it is the least square minimum equation. But what is happening means I have to add constraint. It is subject to the constraint, that is the modulus of g minus hf whole square equal to modulus of nu square. Okay, so the when input equal to noise, if it equal to 0 means input equal to output. So the solution of the problem is given by the equation f dash of u comma v equal to output. Okay, f of u comma v equal to input, f dash of u comma v is equal to output. So f dash of u comma v equal to h bar of u comma v by modulus of h of u comma v whole square plus gamma of p of u comma v whole square into g of u comma v. It is a equation for constrained least square filter with subject to the constrained equation. So where h of u comma v is the degradation function, that is a h bar of u comma v. Okay, it is the degradation function. So it is the complex conjugate of the degradation function. P of u comma v is the Laplacian operator frequency domain and gamma is a parameter which is said to meet the previously mentioned constraint. G of u comma v is the frequency domain of the observed image. So here g of u comma v is the frequency domain of the image. So we need, what is our target? F of u comma v equal to f dash of u comma v. It is our target. So what is happening means I have to remove the nu of u comma v. So I have to remove the noise. It is equal to 0. So if it is noise means 0 means input equal to output. That is our aim. So here h of u comma v is a degradation function, h bar of u comma v is a degradation function, and the complex conjugate of the degradation function equal to p of u comma v. It is a Laplacian operator frequency domain, and gamma is a parameter which is said to be meet the previously mentioned constant g of u comma v, and it is a frequency domain of the observed image, and it is a f dash of u comma v. So it is f dash of u comma v is the frequency domain, and h bar of u comma v equal to degradation function. So it is the frequency domain estimation of the undegraded image. the routine is written as the ideal language. It is the source code of can found in the least square underscore dot PRO dot in. It is a library substance of the ideal distribution. Okay, it is completely software related. That is ideal language. So image data in the constraint least square filtering. What is the image data? A two-dimensional array constraint the pixel values of the input image. What is the degradation function? A two-dimensional array representing the transfer function that describes the image degradation and the degraded image as modeled as a product of the true image with a degradation function and the addition of the noise representing of g of v comma v equal to h of v comma v into f of v comma v plus n of v comma v into g of v comma v. Here n is the noise, it is the input. Here h of v comma v and g of v comma v are the output images and input images with noise is added. So a two-dimensional array representing the transfer function that describes the image degradation. So the degraded images are modeled as a product of the true image with a degradation function and addition of the noise is representing as g of v comma v equal to capital H of v comma v into f of v comma v plus n of v comma v into g of v comma v. So it is observed that the image in the frequency domain capital H of v comma v is the degradation function, capital F of v comma v is the true image in the frequency domain, and n of v comma v is the noise function in the frequency domain. So it is in the practically what is the advantage of constraint least square filtering is the restoration filter presented in this dissertation is the relatively simplicity of the filter. It is a synthesis algorithm. So orally it is the observing of the image. The frequency domain h of v comma v is the degradation function and f of v comma v is the true image of the frequency domain. N of v comma v is the noise function. So how many are there here? Input, output, noisy and degradation function. Okay, these are all added here. Frequency domain h of u comma v is the degradation function, f of u comma v is the input image that is a true image, and n of u comma v is the noisy function of the frequency domain. So practically what is the advantage of CLS is the restoration filter presented in the dissertation is the relatively simplicity of the filter synthesis algorithm. So unlike the algorithm for computing the C type D and C model based on the Wiener values, it is not necessary to estimate the energy spectrum of the scene and the noisy. So instead of CDC model, we are taking constant least square CLS restoration filter values can be computed directly from your knowledge of the imaging system. So when constraint least square CLS image restoration is a linear image restoration technique in which the smoothness of the restored image is maximized subject to a constraint on the fidelity of the restored image. In this context, smoothness is a subjective attribute of image quality that is used to describe the extent to which an image has a high frequency pixel scale in detail. If you are controlling the image smoothness in the restoration applications, the importance of causing of the high frequency features may be spurious and enhanced noise. Okay, so finally what they are telling, constant least square image is the restoration image. It is a linear, not a non-linear. It is a linear image restoration technique in which we are applying the smoothness of the restored image. Okay, what is the input image is there? We are applying the smoothness for the input image. That is the degradation function with the output image is the output without noise and without blurring. That is a restored output. Restored means output image is the replaced with input image. Okay, f dash of x comma y is replaced with in the place of f of x comma y. So it is a maximized subject to constraint on the fidelity of the restored image. In this context, smoothness is a subjective attribute of a image quality that is used to describe the content which is an image and high frequency pixel scale in detail. So when we are controlling the image smoothness in the restoration applications, it is important because high frequency features may be spurious, enhanced noise, that is the least square filtering. It is the block diagram of process of least mean square filtering, constrained least square mean filtering. Okay, so it is the input function f x x of n, and it is going to the h bar of n, y bar of n, and it is going to the h of n. Okay, it is the h of n, h bar n. Okay, it is the unknown system. It is the adaptive filter. Okay, which is going to the y bar of n, y of n. Okay, so v of n is the interference. It is the unknown system. It is the adaptive filter. Okay, finally it is going to the d of n, and it is finally going to the output. So input x of n equal to output e of n. Okay, between the input and output, what is happening? Okay, input in the output, it is the adaptive filter is added to remove the blurrings, and unknown system is added, y of n, y bar of n. Here d of n, degraded function. That means f dash of x comma n equal to f of x comma n. So here interference is added and degradation function is added to removing the blurrings and reduce the noise. Okay, here finally input equal to output, that is x of n equal to e of n. Okay, it is a block diagram of least mean square filtering process. It is another example of VNR versus constrained least square mean filtering. Okay, so here figure A and figure B is there. In the figure A, it is the VNR filter, and the figure B is the constrained least square filtering. Okay, so it is the equation of VNR and it is the equation of CLS, constrained least square filtering. Here RW of x equal to omega 1 minus omega 2. Here RCL is equal to omega 1 minus omega 2. So what is happening? You can observe this one. What is the differences? Okay, it is partially like this. It is looking like this, but it is here three stages, multiple stages are there. Okay, it is like a zigzag, but it is like a one increase to decreasing to increasing, increasing to decreasing, like this. Okay, so it is a difference of VNR to CLS filter. Okay, so it is about constrained least square filtering. So in the constrained least square filtering, it is the function which reducing the degradation of the noise in the image based, which are using mean and variance of the degradation of the noises. It is also called CLS, constrained least square filtering. Okay, and in the constrained least square filtering, it is the deconvolution process which are using for the deblurring of the image. And here the CLS image restoration proposed by Hunt in the 20 years ago, it is a linear image. It is a linear image restoration technique which is for the smoothness of the input image, which is restored with the input image, with the original image, and it is maximized subject to the constraint of the fidelity of the restored image. Okay, it is one example of original image. In this original image, what is happened? Noise is added. So what is noise here? Blurring is a noise. It is one type of noise is added to the original image. Okay, then what is happening? Input is a noisy image, but output I need noiseless, means unblurred. Bloody image is converting to the unblurred image. How it is means? Here I have applied least square filtering process. Okay, least square filtering is a function reduces the degradation or noise of the image based on the mean and variance of the degradation and noise. It is also called least square, constrained least square filtering, CLS. Okay, and it is a degraded image is modeled in the spatial domain. It is the equation equal G equal to HF plus nu equal to noise. It is a degradation function. Okay, H is equal to degraded function, F is the input function, nu is the noisy, okay, blood image. Output G equal to, when I'm using this one, we are removing the noise. When I am removing the noise, then input equal to output. So it is the equation of constrained least square filtering and is subjected to the problem solving with filters, means f dash of e comma v equal to h bar of e comma v by h of e comma v whole square plus gamma of p of e comma v whole square into g of e comma v. It is the constrained least square filtering output. Here h of e comma v is a degradation function. So h bar of e comma v is a degradation function applied to the input image. And the frequency domain estimation of the undegraded image, the routine is written in the ideal language. It is the source function of least square CLS.PRO, and it is a library function which is using, these are all using for the image with the software related works of the image, the digital image. And what is the image data? A data is a two-dimensional array representing the data transfer function that describes the image degradation, and the degraded images are modeled as a product of the true image with a degraded function in addition with the noises and representation by g of e comma v equal to h of e comma v into capital F of e comma v plus m of e comma v into g of e comma v. Here g of e comma v is the degraded function and n of e comma v is the noisy function. G of e comma v is the constrained least square filtering, which is a degraded function without noise. Here included the noise, and the observed the image frequency h of e comma is the degradation function, and f of e comma is the true image, and n of e comma is the noisy function. And the practically advantages of the constrained least square filtering is the filtering to representing in the dispersion of the relatively simplicity of the synthesis algorithm. And it is a restoration function, and it is a linear function which is applying the constraint subject to attributes of the image. So where smoothing function is applied to reduce the blurrings and reduce the noise. And finally what we are getting means high frequency features of spurious enhanced noise. It is the example and block diagram of least mean square filtering with inputs and outputs with a degraded function and interference. It is one example of VNR with constrained least square filtering example. Okay, this is about constrained least square filtering. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.